Alright, so what we're going to do in this video is we're going to use tangent in a practical sort of application. And so let's say what we have going on is that there is a building over here, who I haven't drawn the entirety of, that's 100 feet tall. And the building is next to, let's say, a cliff, and this cliff has some unknown height. Now, and not only is the height here unknown, but the distance between the building and the cliff is also unknown. But what we do know is that from the top of the cliff, looking to the base of the building, if we measure that angle, that's 35 degrees. And from the base of the cliff measuring to the top of the building, that's 20 degrees. So then the question becomes, all right, how high is this cliff, and how wide is this is the distance between the cliff and the building? And so, well, the first thing we want to do is take a look at this this angle here, this base and this height, and ask ourselves, is there a way that I can find out what this distance is in terms of this height? In other words, are there trigonometric functions that involve this distance that I could use to then compute this distance? Well, what I do know is that, let's pick a different color here, is that if I took the cosine of this 20 degrees, then that would be this distance d over this hypotenuse. So that's, let's say, d over, I'm going to call it r1 because there's another hypotenuse here that could be r2. But this isn't particularly useful to us because I also don't know what this distance is either, right? So that's not great. On the other hand, the other thing I could say is, hey, tangent of 20 degrees, that is equal to 100, right? The height of the triangle against the base, right? It goes without saying that, our building is standing perpendicularly, and so is our cliff. So if that's the case, then beautiful. That means that the distance is actually 100 over tangent of 20 degrees, right? And so now we can solve for that distance, and we can use software as usual to compute the particular values. So just remember to make sure that Desmos is set to degrees, because if you set to radians, the values will be different. And so we can note that the tangent of 20 degrees is about 0.364 or so. And then 100 over tangent of 20, let's just call that 2744.75. You know what? We should put that side by side there. Make it a little bigger. So $7.5. Alright, so that gives us this. And so then the question is, how can I find now? How can I find this height? Well, I can't really use this triangle anymore, right? because this triangle doesn't involve this particular height, but this triangle does. And the one angle for sure I know about this the one angle I know for sure is this 35 degrees here. I can also infer some other angles because this is a right angle here as well. And since the angles have to add up to 180, this other angle has to be 55 degrees. And so, once again, I don't know this hypotenuse here, but if I use tangent as my trigonometric function of choice, then I can get away from having to know what the hypotenuse is. So if I'm just looking at this height, one thing I could say is, oh, this is 55 degrees. So tangent of 55 is h over d, which is about h over 274.75, right? And that means that h is about 274.75 times tangent of 55 degrees, right? And so that is a way that you could go about finding that height. But there's another way to go about finding it. Notice that if you turn your head sideways and you look at this angle here, let's say you're looking at it from this angle, and this is the base, then this would be the height, right? So the other thing we could do is we could say, hold on now, if I take tangent of 35 degrees, that's the opposite side over the base height, which is about 274.75 over the base height. So the base height is about 274.75 over tangent of 35 degrees. So we have these two different ways of thinking about what tangent or what this height might be in this case, both in terms of tangent, but tangent in terms of different angles, and they should both be the same. So let's go ahead and compute these two ways to find the tangent. 0.75 times tangent of 55 degrees was one of our ways, gives us a height of about 392.38 feet. On the other hand, 274.75 divided by tangent of 35 degrees gives us a height of about 392.38. Again, that's exactly the same thing, right? And of course this should be the same thing because I'm not measuring two different cliffs. It's the same cliff. That's the height, right? If I measure it different ways, it doesn't matter. It's the same height. So I can go back up here and say, well, either way, the height is about 392.38 feet. We should know that this is feet as well. Everything else is feet. And now that we have both the space and the height, if we wanted to find either one of these hypotenuses, we could with Pythagorean's theorem. We don't have to go to trig for that, but that wasn't what was asked of us, but we should feel confident that we could do that. All right. Thank you very much. If you have any questions or comments, email them to me or post them in the discussion board. I will see you in the next video.